All right, good morning, guys. This is adding and subtracting monomials. So, when you're adding and subtracting monomials, this is combining like terms, except we're going to use more than just one variable. But our variables and exponents must be the same in order to combine these. They have to be the same. If you can't combine it, then you just leave it. So for number one, we'll start out nice and easy. Our variable is x, and our exponent for both of those is 1. So yes, we can combine them. We're just going to combine the coefficients. 17 minus 25 is negative 8. And we do not change the variable nor the exponent. It stays the same when you're adding and subtracting. This is just combining like terms. So if you just watched my exponent rules video, this is the very first line. We're not doing anything with the exponents. We're not adding or subtracting the exponents themselves. We're just making sure that they're the same and combining the coefficients. So the same thing for number 3. This is negative 15 a cubed bc. And then we have positive 6 a cubed bc. So they are the same. So in our final answer, we will have that a cubed bc because we're just adding here. Now, negative 15 and positive 6, those are different signs. So we're going to subtract those. 15 minus 6 will be 9, and we will take the sign of the bigger number, which is negative. Now look at number 5. We have AB and we have AC. We cannot combine these terms because our variables and the exponents must be the same. They are not the same. So this is what we would consider prime, or you can just leave it, right? So for this one, you can just put prime as in it is finished, or more simplified, I guess would be the better word. Prime is more when you're talking about factoring, which we will get to eventually, but not right now. Simplified is more the better word. Okay, so let's get down to some more tricky ones. Let's do number 13. So now we have y squared, and then y squared, and then y again. So our variables have to be the same, and our exponents have to be the same. So as you can tell, y squared has 2 terms. That'll be 13 and 4, so that'll be 17y squared. And then 9y and negative 31y are the same, so that will give us a negative 22y. 17y squared minus 22y, and we can't combine those because the exponents are not the same. The variables are, but the exponents are not. So to find the sum of 16y squared and negative 5y, we're just going to add those together. 16y squared plus negative 5y squared, and that will give us 11y squared. And then subtract from, these are turnaround words, so we have negative 15a minus 9a, subtract from are turnaround words. Those are the same sign, so we're going to combine those two. Take the sign of the bigger number, and again, a is just our power. We are not raising this to the second power or anything like that. So we're going to keep going to multiplying monomials. When we are multiplying monomials, we multiply the coefficients, and then we use the product rule, which is adding, to simplify the exponents. So this is just like what you saw in our exponents review. X to the a power and x to the b power. When we are multiplying these monomials, we are going to add the exponents. Hopefully this is something that you've already seen before, and this isn't brand new, but this is something that you need to know. This is vital for any future math class. So for product rule, we are going to add these. The variables are the same, so we're going to add up top. That'll be x to the 5th. Skipping down to number 4, we're multiplying here. So with our coefficients, again, we just multiply them. 3 times 5 will give you 15. And then for our exponents, you will add them. So our exponents are 6 and 2. We add them to get 8. For number 6, we are multiplying our coefficients. So that will be a negative 12. And then for our exponents, we're adding. So that will be a to the 5th, 3 and 2. And then for this b, this is b to the 1st. Remember that. So this is b to the 6th when we add that 1 and 5. Okay? We'll do another one like that. We'll do number 7. We need to multiply our coefficients. So 8 and negative 3 will give us a negative 24. And then for our exponents, we're going to add them. So that's x to the 8th and y to the 11th. For number 10, we are going to multiply our coefficients again. So 6 and 7 is 42. And then this is m to the first and m to the second. So that's going to give us m to the third. And then we have n to the first and n to the fourth, and that's going to give us n to the fifth. Now, some of you may be saying, whoa, they're not the same. They're not the same term. So one of them has 6m. Shouldn't they all have an m or shouldn't they all have an n? No. When you are multiplying, you just multiply everything and put it together. You were most likely thinking of before where we had to have the same variable and the same exponent to combine them. That's only with adding and subtracting. When you're multiplying, you can multiply any two things together. And it also can get a little confusing when you throw fractions in there, but it's not too bad because we know how to multiply fractions. So we have a -6. Anytime you multiply fractions, you multiply straight across. So that's -6 over 1, or -6 times 1, and 1 times 2, which -6 divided by 2 will be 3. And then that'll be a to the third power and b to the second power. All right, now for number 16, they are going, or 16 and 18 I'll do with you. They are going to give you product rule, multiplying, and adding and subtracting. Okay, so it's a two-step problem. So first we are going to first we're going to multiply the 2 and the 4. That'll give us 8. And then we add the exponents. That'll give us x to the 6th and y to the 5th. Then we'll do the same thing over here. We do 3, adding the exponents 4 and 2 of the x's. That'll give us 6. And then 4 and 1 of the y's. That'll give us 5th. Now, we are adding in this next step. And when we're adding or subtracting, we learned before that we have to have the same variables and the same exponents. So we are combining like terms here. 11 x to the 6th power, y to the 5th power. Since we are adding, those exponents stay the same. They had to be the same variables and the same exponents, which they are, so we can combine the coefficients, and then we do not change anything else. Think of that kind of as if I gave you like 8x plus 3x. You would just add the exponents, or add the coefficients, that will give you 11. You didn't change anything else, right? Same thing here. Those variables and coefficients, or variables and exponents are the same, so we just keep them the same. And for number 18, there is nothing to do with this 19m to the 8th, n to the 8th. And then we will combine and multiply these. So 4 times 3 will give us 12, m to the 8th power, n to the 8th power, because we are adding those two. We do have the same variables. We do have the same exponents, so we can combine those. 19 minus 12 will give me 7, and then our variables and our exponents stay the same. So, for example, what if this n right here had turned out to be a 7? What if our answer had a 7 there? Then there's nothing else we can do. That's m to the 8th, n to the 8th, and m to the 8th, n to the 7th. So we would not have been able to combine it, and that would have been our final answer. Again, that's just an example. Our final answer, we did have an 8, and our final answer was 7, m to the 8th, n to the 8th. So that is adding, subtracting, and multiplying monomials. And if you got any questions, feel free to reach out through email. I hope you guys have a wonderful day.